if you've got, Tony, would you mind killing one set of lights? That'd be great. So, to know if you have it or not on your machine, just press the PRGM button. It's program. It's right by the stat. It's below the stat button. It's above the COS button. Just press that. It's called coins.
Oh, I got it.
If you've got it, I gave it out weeks and weeks ago when I shared another program with you guys. But sometimes stuff gets erased. I mean, these things get erased pretty easily. So you might not have it. If you don't have it, I'll wander around in a moment and we'll give it to you so you have it. Okay? So grab it. Grab it. What do I say? Grab it. Press enter on it. It's probably the first one on your list, I'm guessing. So just put it up. So this kicks you up to the home screen. You have to press enter again. So press enter again. The first thing, I coded it so that it asks you, how many sides does your coin have? Now you have to realize when I talk about a coin here, I'm not just talking about a two-sided coin. I'm talking about any number of sides of a coin. For example, the experiment we were doing last week with the cards, pulling the cards out of a deck, is really, if you think about it, a four-sided coin. It's a coin that generates hearts, clubs, spades, or diamonds. That's a four-sided coin. Four-sided coins do exist. They look like little pyramids, four triangular faces. They actually are used in certain games. Okay? But this one here actually just simulates one for you if you were to type in 4. But let's start by typing in, just type in 2. Type in 2. This will be a two-sided coin. If you press enter then, it will, in the code, start flipping. It'll start flipping. And I'll show you the code in a second so you see what I'm talking about by flipping. But it kept track of its flips. And it took 2 trials until it saw a repeat. It didn't tell you which repeat it was, whether it was heads, heads, or tails, tails. So obviously it went heads, heads, or tails, tails. I don't know which. But it also took 8 flips until all the sides showed, which means it went tails, 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 heads, or heads, 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 tails, which is extraordinary. I'm guessing you guys didn't get that. I'm guessing you guys got something different, which is the whole point. You should get something different. Because remember when we did it in class? The exact same thing happened. We all got different results, and we collected our results over time. Natasha, what's up?
What if it says 1 of each?
Yeah.
With an explanation point?
Mine did too.
Oh, it said 1 of each, and then hit enter, and then enter again. And then it came to
So
this.
you have to do it a couple
I
times.
obviously wrote that into the code. I'm not seeing it right now. 1 of
It
each.
showed up right before that.
That's okay. That's all right. That's just a very no. That's okay. I'll get it too. It's in my code as well. That's a very special case. Hold tight.
Oh,
Ours is a special case.
Did it right?
Ours is a special case.
Hang on. So you're saying boom.
Yeah.
So what that means is you got the heads and then you got the tails. I wanted you to. See, I think back 5 weeks now. I wrote that into the code for some reason. I don't know why. Let's roll again. 1 of each. Why did I do that?
Maybe it's just to make it simpler that you did it 2 times.
No. I know why it is. I know why it is. It's nothing to do with the coins at all. It has to do with when you have more than 2 sides. Like for a die, when you actually throw the result and it goes 1, 2, 3, 4, 5, 6, which doesn't happen very, very often. I wanted to make sure that stood out as a very, very unique event. It doesn't happen as a unique event very often with a coin because it happens all the time. It happens half the time actually. So, but I'm not going to have you simulating a coin flip. I just want to show you that it can work for a coin flip as well. Thank you. I had forgotten I had done that. I had totally forgotten I had done that. That's pretty cool actually. Anyway, press enter. When it says roll again, change die, or done, hit change die. Hit change die.
Wait, how'd you get out of that?
Hit
Well,
enter.
hit enter. And then it gives you a menu. Yeah. Now, just so you know, I'm going to go back to the coins real quick. Yeah. Whenever this thing is doing this up in the corner, you just press enter to get out of that. So when it was on that screen showing you did this and this, just press enter again and it pops it out. So change the die, and if you change the die to a 4-sided die or a 4-sided coin, now it's simulating the card pulls. It doesn't actually show you the card pulls on the screen. This card pulls are being dealt with within the program, which I'll show you momentarily. But when you do this, it took 4 trials until a repeat and 5 until we saw all the suits. So in other words, it went something like clubs, hearts, diamonds, clubs. That would be 4 trials till a repeat. And then it took 5 with clubs, hearts, diamonds, clubs, spades. That would be 5. Then you saw them all. So So it's doing the same thing you guys did in class, but it's doing it automatically for you. Does that make sense? Does that make sense? You guys buying that? Okay, fair enough. Okay, beautiful. Now, what I'd like to do is change the die again, because I want to start getting you guys collecting. I want to start getting you guys collecting what would happen on a 6-sided die. That's the last experiment I want to do randomly, which is experiment with rolling single dice. And the reason I have you doing it with technology versus rolling it by hand is this could take a while rolling it by hand. Hopefully you remember from class last week, and it's been a long time, so you might not. It took a lot longer until we saw all faces on the cards than it did until we saw the heads and the tails on the coin. And there is a neat problem that's tied to that. It's called the coupon collector's problem, which we're getting to here momentarily. Which, if you have a bunch of things out there, how many things do you have to get? How many times do you have to try to collect them until you get them all? My son goes through this all the time. One of your quiz questions for this week, I believe, is related to it. Lego puts out these little tiny bags of little minifigures. And they have 12, I think it's 12 or 16, I forget how many. 12 or 16 in each series. And he's big about collecting them. And he's like, I'll go out and buy 16, Dad. I'm like, well, okay. And that might happen. But what might happen more realistically is you'll get repeats. So the question is, how much would he have to bring on average to the store with him? Knowing that they cost, say, $2 or $3 a piece. On average, how much should he have to bring to the store to guarantee that he'll actually get at least one of each of the minifigures? And that's the question we're going to answer, Tori. Tori's like, oh my God, this sounds like hell. Well, that's where technology comes in handy. Technology comes in handy because it will give you that data. We can average our results, and I actually have the theoretical answers, which we'll collect against momentarily. So what I want you guys to do, if you have this program right now, is start running it on a 6-sided die. So just type in 6 for 6 sides, press enter, let it do its thing. Good. It took 5 trials until I got a repeat. So who knows what that was, 1, 2, 3, 4, 1, or something like that. And it took 14 until I saw everything at least one time, which means I rolled the die until every side showed at least one time. Does that make sense? You guys buy what's going on? Then just press it again, roll it again, keep doing this on the 6-sided dice. 6-sided dice. It's thinking. 4 and 12 that time. 4 and 12 that time. Roll again. 4 and 8 that time. So what I want to do is I want to start collecting some numbers.
That's weird. You and I got the same number.
Do it again. We may have to reseat our randomizer. Hang on. Do it again. Do it again, Shelby. 4 and 17?
Yeah.
That's okay.
Stop copying me.
I'm just going to reseed mine. Hey, let's all do it right now. This is a good idea. Thank you, Shelby. I hadn't bothered Sweet, I can't think of repetition right now. Sweet Carl Friedrich Gauss. Yeah, doing it. Let's all reseed our randomizers right now. I know why. I know why. Remember my battery got pulled, my memory got erased? It reset the factory resets back to 0, which means both of ours were set back to there too. So let's fix that right now. Everybody, type in, quit the program. Say, when it says done, just go done, kicks you out, you're done now.
Oh, what?
Just keep pressing till you get to roll again, change die, or done. Done will kick you out. Thank you, Shelby, for saying this. We do want random data. I appreciate that. So now I'm at the home screen. You can just press clear if you want to clear it out. I'm going to type any number that will be significantly different than anybody else's number in the room. I always just default to my birthday. So 6/28/1973. They know how old I am. So any number that you think will be significantly different than anybody else in the room. Okay, birthdays are a pretty good bet, especially with the year on there. Especially with the year on there.
I'm so young.
And then press the button right above on, which is the store button. So these little arrows should show up.
Yeah.
And then press the math button. Press the math button. Go over to PRB. Make sense? Go over to PRB.
Yeah.
And then just press enter for rand. So now your home screen should look like this. 6281973 store rand. And then just press enter. And it won't look very interesting right now. It'll just look like that. It'll just give you the number back. But now we will all get different numbers for every single random number generation. I'm glad you said that. I had forgotten that I reset the memory.
I was like, why are we getting this?
And do you remember I had you guys do that a while ago? I had you randomize your TIs. It's been a couple weeks now. And I just assume that we've been using the randomizer so much, and chances are all differently, that there would not be any need to re-randomize, but unless you reset it, in which case we're defaulted back to the same. I'm glad you said something. Elena, what you got?
My calculator does not change. It always says 1.
Hold that thought. We'll come back and fix it. I may have to upload the program again. It's very easy. Just FYI, I'm going to show you the guts of the program real quick. So don't you guys usually do this. I don't want you to get in here and mess around with the code. But it's really easy if you interrupt the program while it's working. If you get a go-to error, it'll put you inside here. And that's what you don't want to do, because if you get in here, you start pressing clear, you're erasing lines of the code out. So right here, friends, this is where the rolling is happening in the program. Rand int, remember that command? 1, comma, s. Guess what s is? S is the number of sides you told it. So if it's 1 to 2, 1 to 4, 1 to 6, however many sides you put in, it generates a random number between 1 and that number, calls it x, sticks x into a list, which has already been created up above, if you look up here, right there. L1 keeps track of all the possibilities. So if you put in 2, it puts 1 and 2 in L1. If you put in 4, it puts 1, 2, 3, 4 in L1. If you put in 6, it puts 1, 2, 3, 4, 5, 6 in L1. If you put in 62, it goes 1 through 62 in L1. Don't do that, because you'll be here all day running trials. It's going to take a long freaking time. We use other technology for that. So then it starts rolling, and this is the part that took me a while to write. While the product of list 2 is 0, now this might seem a little strange, but what it does is, it puts zeros in list 2 before it starts the experiment, and then it starts rolling, and it puts 1, 1, 1, maybe a 2 in list 2. It keeps track of how many of each side you get. And then it checks the product of all the numbers in list 2, and as long as that product is 0, it keeps rolling. Do you see why? This is a bit of a computer science question, but do you see why it will keep rolling as long as that product is 0? If the product is 0, what haven't I seen yet? This is weird. Let me do it in writing versus verbally, because I think here's how the program works. Yeah, this is a strange question. I should probably do it via writing instead of... Okay. So let's say we're rolling our 6-sided die. Okay, the first thing the TI does is it goes, okay, L1, 1, 2, 3, 4, 5, and 6. Those are the possibilities. And then L2, it fills those with zeros. And then it goes, okay, little TI, go start rolling. And what's the first thing it rolls? You guys call out one. It calls them. It got a 1, so then that becomes a 1. And then it rolled a 2, and that becomes a 1. What did it roll next? 6. That becomes a 1. What did it roll next? I hear 1? Good. 1. This becomes a 2. What did it roll next?
4.
4. That's a 5, isn't it? 4. Now, before we go any further, it has to roll and keep track of how many trials it takes until it sees everything at least once, right? So how's it going to know when it's seen everything at least once?
No zeros.
There aren't going to be any zeros in that list. But you can't tell a computer, keep doing this until you don't see any zeros in the list. It doesn't understand English. So I used some algebra. And I said, multiply all the numbers in this list. As long as the product is equal to 0, keep rolling. Because the only way that we haven't seen everything is if there's a 0 in the list, right? So, what did it roll next? 6. What did it roll next?
5.
5. Is it going to keep rolling?
Yeah.
Yes, because the product is still 0. What did it roll next?
3.
3. Oh, 2 first. Then
3.
3. Is it going to keep rolling now? Now it's done. Now it's done, and it adds up that list, and it says that's how many times it took until you saw at least one of everything. That's that product line. So that's what I was trying to get across there. So you can't talk to a computer like you talk to a person, which I think is a good thing. Because think about how many times we confuse each other, like I just did right there. I had to put it in mathematical terms for you to see, which is good. I'm glad you guys looked kind of confused by that. That was good. I should have known you to go straight to this in the first place. It's also keeping track of the first time you see a 2. Remember that first 2 we saw? I think it was on 1. Somebody said 1, then 1 again. It also keeps track of the first time you see a 2. And it puts that down. It took this many trials until you got your first repeat. And then it keeps going until there's no zeros left, and then it says there's this many times until you've got at least one of each. So that's what this whole code is doing. The one of each that you get every once in a blue moon, Natasha, thank you for putting that up, that would have meant that you rolled exactly 6 times, and got one of each of the sides in the first 6 rolls. Now, notice the TI doesn't tell you it took this and this. I wanted to make a big deal about it. But you know what the answers are. If you went 1 through 6 and saw one of each, how many times would you have to roll until you got a repeat? 7! Obviously, right? If you rolled 6 and you saw one of each, whatever you rolled next is going to match one of those first 6. So it'll be 7. And then the answer for how many times did you have to roll until you saw one of each was 6. Was 6. Generally speaking, it's going to be fewer trials to get a repeat than it is to see one of each. Did you notice that in my results? It seemed that was almost always lower, fewer to get a repeat than it was to get one of each. That's the one case where it's not, yeah? That's the one case where it's not. You roll all 6 in the beginning. Now, it doesn't happen all that often. It happens about 1 every 100 trials. So guaranteed, in here, somebody's going to see it at some point. Okay? I shouldn't say guaranteed. I said, probabilistically speaking, somebody's going to see it in here. 1 out of approximately every 100 trials. If you do, make a lot of noise and wave your TI around a little bit. Just so we celebrate it. Okay? It's a big deal. Big deal. And the more sides that it die, the more rare it is that it happens. So make sure you wave TI around a bit. And we'll collect our data. So everybody, if you would, run that thing like 20 times a piece and write down all the data that you get. Okay?
On 6.
On 6, please. Please on 6. Collect all that data, and then we'll analyze all the data, yes? And we'll see how our data stacks up and what the overriding pattern is. And I want to get your guys' opinions about how long it should be, do you think, on average, until we should see all the sides of the dice. And that's what this is helping us answer. Good. Now who needs the program? Cassie needs it, Galena needs it, Tori needs it.